Panitia, ID. Ya, ayo Pak. Panitia aja lah.
Bismillahirrahmanirrahim. Excellencies, distinguished guests, participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. In the name of Allah, the most beneficent and the most merciful, may peace, mercy, and blessings of Allah be upon you. Good morning, and we are delighted to welcome you offline from Keynote Muraya Hotel Banda Aceh and online from anywhere for the opening ceremony of the 4th International Conference on Experimental and Computational Mechanics in Engineering, Icecme 2022. Selamat pagi, kami sangat senang menyambut Anda secara offline dari Hotel Keynote Muraya Banda Aceh dan online dari manapun untuk upacara pembukaan International Conference on Experimental and Computational Mechanics in Engineering, Icecme 2022 yang keempat. My name is Raihandara Lufika. I am the master ceremony for today's event. I would like to send my gratitude greetings to the Director of Universitas Syah Kuala, Professor Dr. Insinyur Marwan, IPU, the Dean of Engineering Faculty, Universitas Syah Kuala, Professor Dr. Insinyur Alfiansah Yulianur, BC, the General Chairman of the 4th International Conference on Experimental and Computational Mechanics in Engineering, Icecme 2022, Dr. Ing Insinyur Teguh Edisah Putra, ST MSc PhD IPM ASEAN Eng. The honorable keynote speakers, Assistant Professor Dr. Fitwi Y. Hages from Sultan Qaboos University, Oman, Associate Professor Dr. Hendra Hermawan from University Laval, Canada, Dr. Terence Esomba from National Central University, Taiwan, Insinyur Jaka Kirwanto, IPU, Operational and Production Director of PT Pupuk Iskandar Muda Indonesia, Dr. Insinyur M. Dirhamsyah, MT, IPU from Universitas Syah Kuala, Indonesia, the representative from Solusi Bangun Andalas, and also the head of LPPM, Professor Taufik Fuadi Abidin, presenters, participants, and the steering committee of the 4th International Conference on Experimental and Computational Mechanics in Engineering, Icecme 2022. The 4th Icecme is an annual conference event held by Mechanical and Industrial Engineering Department of Universitas Syah Kuala. All of our conferences features many honorable keynote speakers from all over the world, including Australia, Germany, India, Japan, Brunei Darussalam, Malaysia, Thailand, and today from Oman, Canada, and Taiwan. And we also supported by partner university and co-organizers, which are Universitas Andalas, University Kuala Lumpur, Malaysia, and Universitas Samudra Langsa. This conference is bringing together academia, researchers, business entrepreneurs, practitioners, and policymakers who are responsible for delivering sustainable and eco-friendly solutions through advanced information engineering and technology. for competitive advantage and cost savings in modern industrial sector, as well as public and business sectors. And this conference provide a great opportunity for prospective participants to share their recent theoretical knowledge, research findings, and also experiences in dealing with sustainable information engineering. As such, this conference will feature presentation by international speakers, which are cutting-edge session topics. And this event is brought to you on the support of our general sponsors of the 4th Icecme 2022, PT Pupuk Iskandar Muda, Medco INP Malaka, and Solusi Bangun Andalas. And to begin the opening ceremony event, we will listen to the reciting Quran, Salawat, and Dua by Muhammad Hafiz. For Muhammad Hafiz, the stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. وَوَهَبْنَا لَهُ إِسْحَاقَ وَيَعْقُوبَ كُلًّا هَدَيْنَا وَنُوحًا هَدَيْنَا وَنُوحًا هَدَيْنَا مِنْ قَبْلُ وَمِنْ ذُرِّيَّتِهِ دَاوُودَ وَسُلَيْمَانَ وأيوب ويوسف وموسى وهارون وكذلك نجزي المحسنين وزكريا ويحيى وعيسى وإلياس كل من الصالحين وإسحاق وإسماعيل واليسع ويونس ولوطا وكلا فضلنا على العالمين. ومن آبائهم وذرياتهم وإخوانهم واجتبيناهم وهديناهم إلى صراط مستقيم. واجتبيناهم وهديناهم إلى صراط مستقيم. صدق الله العظيم. Diharapkan para hadirin untuk berdiri sejenak. Salatullah, salamullah ala taha Rasulillah. Salatullah, salamullah ala yasin habibillah. Tawassalna bismillah wa bil hadi rasulillah wa kulli mujahidin lillah bi ahlil badri ya Allah. Salatullah, salamullah ala taha Rasulillah. Salatullah, salamullah ala yasin habibillah. والآفات والنقمة ومن هم ومن غمة بأهل البدر يا الله صلاة الله سلام الله على طه رسول الله صلاة الله سلام الله على ياسين حبيب الله. Diharapkan para hadirin untuk duduk kembali. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karimi wa 'azimi sultanik. Allahumma salli ala sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. Allahumma inna nas'aluka ridhaka wal jannata wa na'udzubika min sakhatika wan nar. Allahumma innaka afuwun karimun halimun tuhibbul afwa fa'fu anna ya Allah ya Karim. Allahumma ighfir lana dhunubana wa liwalidina warhamhuma kama rabbayana saghira. Allahumma ighfir lil muslimina wal muslimat wal mu'minina wal mu'minat al-ahya'i minhum wal amwat birahmatika ya arhamar rahimin. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana la tuzigh qulubana ba'da idh hadaytana wa hab lana min ladunka rahmah innaka antal wahhab. Rabbana atina fid dunya hasanatan wa fil akhirati hasanatan wa qina adzaban nar. Rabbana taqabbal minna innaka antas sami'ul alim wa tub alaina innaka antat tawwabur rahim. Wa sallallahu ala sayyidina Muhammadin nabiyil ummi wa ala alihi wa sahbihi wa baraka wa sallam birahmatika ya arhamar rahimin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Muhammad Hafiz, for the beautiful reciting. For your information, Muhammad Hafiz is the Mechanical and Industrial Engineering alumni of Universitas Syahwala who just graduated. He won several MTechis competitions. Then, for a brief moment, we would like to invite you to rise and sing Indonesian anthem, Indonesia Raya. Hadirin dimohon berdiri. Hadirin dapat duduk kembali. Excellencies, participants, ladies and gentlemen, I would like to invite Dr. Teguh Edi Saputra, the General Chairman of the 4th Icecme 2022, to deliver the opening speech. Ladies and gentlemen, please welcome Dr. Teguh Edi Saputra.
Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, alhamdulillahirabbil alamin wassalatu wassalamu ala alihi wasahbihi wasallim. Rektor Universitas Syahkuala, Dean of Faculty of Engineering Universitas Syahkuala, Head of Institute for Research and Community Service Universitas Syahkuala, our keynotes, Dr. Fitwi Agus from Sultan Qaboos University, Oman, Dr. Hendra Hendrawan from University Lapal, Canada, Dr. Terence Esomba from National Central University, Taiwan, Insinyur Jaka Kirwato from Pupuk Iskandar Muda, Indonesia, and Dr. Muhammad Ramsyah from Universitas Syahkuala. Our guests and participants, welcome to the 4th International Conference on Experimental and Computational Mechanics in Engineering 2022. It is the first time our Department of Mechanical and Industrial Engineering, Faculty of Engineering to conduct this seminar. We believe this is the perfect forum to share our knowledge in field of computational mechanics, metallurgy and material and science, biomechanics, mechatronics and robotics, manufacturing, processing and system, industrial system and engineering design, as well as thermal and fluid engineering. This year we received 77 papers coming from Estonia, South Korea, Malaysia, Brunei Darussalam, Thailand, India, and of course Indonesia. And today we invite 74 papers to be presented at this conference. All presented papers will be published in one of the following publications: International Journal of Automotive and Mechanical Engineering, Defect and Diffusion Forum, Key Engineering Material, and Lecture Notes in Mechanical Engineering. We would like to thank to our co-organizer, University Kuala Lumpur, Malaysia, and Universitas Andalas, Padang, and then Universitas Samudra, Langsa. The highest appreciation to Pupuk Iskandar Muda, Mesco Energy, and Solusi Bangun Andalas for supporting this event. And finally, to all members of the organizing committee, International Scientific Committee, and the reviewers, thank you very much for your contribution to successfully this conference. And finally, to all participants, please enjoy this conference, and we hope you can share, openness, and develop international relationship in the future. Thank you very much. Thank you very much to all, and Professor, and from Dean of and the head of FPM. Thank you very much. Thank you, brother. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Edi Saputra, for the opening speech. And then we're pleased to have Professor Dr. Insinyur Marwan, Rector of Universitas Syahkuala, to deliver the opening remarks. We also would like to request Professor Marwan to officially open the 4th ceremony, the 4th International Conference on Experimental and Computational Mechanics in Engineering, Icecme 2022. We'd like to invite here at the stage, Professor Marwan.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. In the name of Allah, the most beneficent and the most merciful, my peace, mercy, and blessing of Allah be upon of you. Excellency, the Dean of Faculty of Engineering, Universitas Syahkuala, and all Vice Dean, Head of LPPM Institute Research, Mr. Syah Kuala, and Excellency keynote speaker and all presenter in this meeting coming from various university, 7 countries as reported by the MC and also chairman of this conference. Honorable university and industrial partner of this conference, thank you for your support making this conference success. Dear colleagues, professor, ladies and gentlemen, on behalf of Universitas Syah Kuala, I would like to express my sincere gratitude and welcome you to the 4th International Conference on Experimental and Computational Mechanics in Engineering, Icecme 2022. Moreover, I honorably welcome our keynote speaker, Dr. Hagos from Sultan Qaboos University, Oman, Dr. Hendra Hermawan from University Laval, Canada, Dr. Terence Asomba from National Central University, Taiwan, Jaka Kirwanto from Pupuk Iskandar Muda, Indonesia, and Dr. Mdir Hamzah from Universitas Syah Kuala. With the theme Enhancing Flight Technology, Innovation and Resilience for Sustainable Development in Society 5.0, I hope that the 4th Icecme 2022 will be able to achieve the objective to providing effective forum for academician, researcher, and practitioner to strengthen academic and industrial collaboration to enhance research and innovation. I believe that academic, government, and industry must not work alone, but must collaborate, because with collaboration, the goal becomes easier, more efficient, and more efficient to achieve, and we can change to a better life and environment. Ladies and gentlemen, I also believe knowledge, research, and technology are for people, mankind, and to help anyone. No matter how much we can accomplish by ourselves, whether it be research or development, is never sufficient in this world of knowledge. Therefore, the focal point, the focal drive of this conference to exchange ideas, and by participating in this exchange, it is hoped that all parties who might benefit from the conference can apply to manage any activities in their area. It is pleasing to note that the agenda of this conference covers a wide range of interesting topics related to all theoretical and practical aspects, such as computational mechanics, metallurgy and material sciences, biomechanics, mechatronics and robotics, manufacturing process and system, industrial and system engineering, engineering design, as well thermal and fluid engineering. Finally, my deepest gratitude goes to the advisory board, organizing committee, international scientific committee, institution, company, and volunteer who have directly and indirectly supported the success of this conference. The committee has organized a vibrant scientific program and is working hard to present highly respected and internationally notorious speaker. Although we try our best, our finest, to be professional, on behalf of Universitas Syah Kuala, please accept our sincere apologies. Should any inconvenience occur before, during, and after the conference, I wish you a very productive conference with exciting and encouraging discussion and exchange of knowledge, so that together we can anticipate future challenge and opportunity in enhancing innovation and research. And also, I would like to declare the conference formally open. Bismillahirrahmanirrahim. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Marwan, for opening the for formally opening the fourth Icecme 2022. And then before the keynote speech sessions, we would like to hold a photo sessions for everyone at the venue. Maybe maybe you can move forward. And then for everyone join us online, please turn on your video and our committee will take the photo. Bapak-bapak mungkin kalau boleh kita maju ke depan karena di
tambah bersih itu rapat-rapat ya. Bagian kursi bisa
Yes.
Buat kursi sendiri. Bagian ini ya. Oh gitu. Saya duduknya di sini apa situ? Sini. Oh, oke. Naik kursi itu. Naik kursi itu. Ini bayar. Duduk satu lagi. Imbang. Jangan tinggi. Oke.
Salah pun lain. Oke. Nah, jangan baru nempel keluar. Belum mancing. Ya, mancing. Siapa? Emang juga. Kupikir udah jauh di sana, nggak jauh orangnya. Ayo saudara yang banyak. Apa? Pindah-pindah ya. Ini lagi di pulau aja.
Participants, ladies and gentlemen. Now we are going to move on to the next agenda. The next agenda is the keynote speech, which will be delivered by Associate Professor Dr. Hendra Hermawan from University Laval, Canada. And the keynote speech will be moderated by Dr. Shifaul Husni, ST MSc from Universitas Syah Kuala, Indonesia. Both Professor Hendra and Dr. Shifaul Husni will join us via Zoom. Can we connect to Professor Hendra and Dr. Shifaul? Are you with us, Dr. Shifaul?
Yeah, I can.
Bapak Professor Hendra, are you with us?
Yes, I'm
Yes.
with you.
Okay, thank you very much. So I will, ladies and gentlemen, please welcome on screen Associate Professor Hendra and Dr. Shifaul Husni.
Okay, thank you, Raihan. Okay, for the next 30 minutes, I will act as a chairman for this session. I hope all of you can hear my voice through Zoom. And my name is Shifaul. As the chairman for this session. First, I would like to welcome all invited guests at this forum. Hopefully, all of you. Department of Mining. I believe I have HF, ZR, and BX kind of titanium alloy. And before we listen to his presentation, I would like to read a little about his background. Dr. Hendra Hermawan obtained his BS and MS from Bandung Institute of Technology in 2002. Berarti di sela-sela boleh berbahasa Indonesia nih Pak ya. And he obtained his PhD from Laval University in 2009. And all his background is in the field of engineering materials. And I would like to inform the participant who want to ask the presenter, please do so after the keynote presentation is complete. Without further ado, I would like to invite Dr. Indra M. Mawan to deliver his presentation. Please, the time is yours. Thank you.
Thank you very much, Mr. Moderator. I would like to check with you if you can see my screen. Can you see? Okay. So, Assalamualaikum warahmatullahi wabarakatuh. I would like to thank my all-time friend, Dr. Sharijal Fona, for inviting me to this respective conference. And thank you everyone for your presence. Hopefully one day I can come to see you in person. I always believe that a forum like this is a good place to initiate collaboration. So before I begin my talk, let me try to convince you to collaborate with me. Where am I right now? I'm 12 hours, no, currently it's 11 hour different from Banda Aceh, or 15,000 kilometers away from University of Siak Kuala. So if you would like to come to my place, you will need to take, if you start from Jakarta, the fastest way is to take Japan line from Jakarta to Tokyo. And then after transit in Tokyo, you can go directly with Air Canada to Montreal. And from Montreal, you can take a bus to Laval University in Quebec City. So, and this is part of our university. And my office is in this building. So this is an engineering building, and my office will be in level 2 somewhere here. If you can see my my cursor. So I would like to add also some more detail about myself. As you might know that we have mostly we have 3 activities as a lecturer or professor. So in teaching, I teach corrosion protection, composite materials, electrometallurgy, and materials property and selection. In research, I do. I'm very interested in studying biomaterials, corrosion, and metallurgy. So especially on metallic biomaterials. I give service to community in this way to research community as editorial board member for several journals. I began my career as postdoc fellow after graduated from PhD, or even before graduate from PhD, a postdoc, an industrial postdoc that was sponsored by a medical company in Barcelona. And then in 2010, I moved to Malaysia, University of Technology Malaysia, to assume a post as a senior lecturer. And then in 2014, I came back to Canada, to Laval University as assistant professor. And since 2019, I got my tenure as associate professor. I also a professional engineer registered with Professional Engineers Ontario. Why it is important here? Because every engineering lecturer here must have a license, professional engineer license, to teach courses that contain accreditation unit. So how can we collaborate? There are some opportunities for students and researchers alike, especially for students from ASEAN countries. Canada offer this Canada ASEAN Scholarship and Educational Exchanges for Development each year to students in ASEAN university, but the student must be ASEAN citizen, ASEAN country citizen. So every professor in Canada can submit one candidacy, and now I'm waiting my internship students, a PhD student from University of Indonesia. He will arrive like maybe tomorrow night. He will be my third students coming under this program, scholarship program. So he will spend here in my lab for 6 months. He will do some research as part of his PhD project. So mostly the project will be done in Indonesia for sure. And during 6 months, he will be using some equipment available in my lab, or if not, available within my network. There's also a program from my tax. This is, for example, the Global Link program. It is also an opportunity for students to come to Canada, sponsored by Canadian government for internship. But it's not only limited to students. It could be also postdoc or even professor can come to Canada through this program. There is also a program from Academics Without Border, which have headquarters in Montreal. And you can propose a project to this organization. And if it is selected, somebody from this organization, could be professor, could be someone from industry, depending on the project, will come to your place and do some capacity building project funded by this organization. And a student who comes to my lab will have the opportunity to experience Canadian research culture or atmosphere, including they will enjoy in Quebec City, they will enjoy a ton of snows. They will experience, if students come from Jakarta, like this time, from plus 30, maybe if they come in January to minus 30, but don't worry, it will be fine. So my research activity is dedicated to student training and also knowledge generation. And one of our main research instrument is this AFM SECM. So it is basically an atomic force microscopy, but combined with scanning electrochemical microscope, which is a very small electrochemical cell controlled by a potential stat. So under the AFM head, we have these small electrochemical cells, and one of the electrode will be the probe of the AFM. So it is very small. We can do topographical characterization and also electrochemical like mapping, okay, to check like surface potential or even electrochemical current generated during corrosion. And these are example of our recent result. So we aim to contribute to the advancement of knowledge one step at a time. This, for example, this paper is a collaborative paper with colleagues from United States on high entropy alloys. And the other one is a collaboration with Japan professor we work on corrosion of titanium alloys, new titanium alloys. And today, actually, I would like to present some result that has been also published in Electrochemical Acta. And this is the title of my presentation: Effect of niobium addition to the corrosion resistance of titanium, hafnium, zirconium, niobium X high entropy alloys in Hang solution. And inside, I will present you some experimental result and also some mathematical modelings to analyze the result. It is my my habit to only present something that has already peer-reviewed in order to avoid mistake, to minimize mistake from myself, and it will be propagated to all the audience. So that's why whenever possible, I only present result that has been published. But inside, you can ask more questions and I can add more insight. So this is actually a work of my PhD student, Ayub Tanji, comes from Morocco. He is now a senior PhD student. He is in 4th year right now of his PhD. So this is the target application of the material used for this research. Maybe some of you know what is this. This is a small implant, small medical device. Is called stent, a coronary stent. It is used to help or to cure cardiovascular disease or blockage in coronary artery. So this stent functions like to keep an artery open, a coronary artery open after being opened by balloon. And what are the important parameters of a stent? If we check the working condition of a stent, so the stent will receive radial pressure, compression from the blood vessel. And also there will be blood flow inside. And also it's not static, but it's dynamic, coming from the heart activity that pump blood. So we have a high pressure systole and also low pressure diastole of the blood pressure. And what are the ideal characteristics of stents? The material should be biocompatible. It should not induce inflammation. Then after inflammation, there will be blood clotting that disturb the flow, the blood flow, and then re-induce the coronary artery blockage. And the strut thickness, okay, this is the strut. So it's like actually a tube, but mesh tube. So the strut thickness ideally should be as thin as possible, but it should also give radial strength. And there is other characteristic like mechanical characteristic for flexibility and deliverability. There's also longitudinal strength and some physical properties like radiopacity. And it should be visible under radiography, which is needed during the implantation by the cardiologist. So the desired stent characteristic, it has to be small diameter, okay, for small artery, because now we also think about carotid stent, which is a stent used to open blockage in the artery that going into the brain. So it may help to restore blood that has been like clogged because of stroke, or maybe this is to mostly to prevent stroke. The stent implantation in the brain artery. It has to be. It must have a thinner strut. Okay, so thinner strut thickness, as thin as possible, but it should maintain high radial strength. If we translate this stent characteristic to desired material characteristic, we want material that has high tensile strength and ductility, and of course high corrosion resistance. The blood is a corrosive medium. It has chloride ions at quite a high amount, maybe almost similar to sea water in terms of chloride content. So we must ensure that our stent material to have high corrosion resistance. And for this work, we propose high entropy alloys which has a high tensile strength and ductility quite high. So it is a yes in terms of tensile strength and ductility, but in terms of corrosion resistance in body fluid, it is still unknown. High entropy alloys are still considered as new materials with so many unknown characteristics, including the corrosion resistance in body fluid. Because in the first development of high entropy alloy, it was not made. It was not meant for biomaterials application. If we check what are the characteristics of commercial stents, for example, we compare the strut thickness, materials, and then tensile strength, yield strength, and elongation. You see, Cyper. This is commercial name from Cordis. Cordis is the manufacturer. It has a strut thickness of 140 micron. So we are dealing with very small devices. It's made of stainless steel 316L. It has a tensile strength about 500 megapascal and yield strength 275 with very good elongation. There's also Endeavor stent made by Medtronic, which is made of cobalt chromium alloys. With high tensile strength and high lead strength, we can reduce the strut thickness from 140 to 91. And if we check the very recent one, this one Promos made by Boston Scientific, they were able to reduce the strut thickness even more to 81 micron. They made their stent from platinum chromium alloys. Okay, and if we see CNC from CNC stent from Abbott Vascular, 81 micron strut thickness, it was made from cobalt chromium alloys of different type, which has a very high tensile strength. And for us, we propose this titanium, hafnium, zirconium, niobium high entropy alloys, which has minimum tensile strength, yield strength, and elongation of 700 megapascal, 600 megapascal, and 15% elongation respectively. Okay, so it's quite high, and these are the value obtained from homogenized alloys. It's not yet treated to improve the mechanical properties. Like you see, start from cast alloy and then homogenized alloys, and we can have this is the X-ray pattern, show single phase, and with some small phase that is detected, but very, very low concentration. And then since its corrosion characteristic is not known quite well, especially in simulated body fluid, we do some corrosion evaluation to this alloy with the objective to evaluate the electrochemical characteristic of the alloys in Hang solution at 37 degrees Celsius, and then to reveal the effect of niobium. You can see it's an NBX, so we vary the content of niobium. So to reveal the effect of niobium on the oxide film formation process and passivation mechanism. So as some of you knows, maybe medical implants or metals that use for making implants like stainless steel 316L, titanium alloys, and also cobalt chromium alloys rely heavily on the formation of passive film to protect them from corrosion. So that's why it is important to understand what is the behavior or the characteristic of passive film. In this case, for our high entropy alloys. So what we did was electrochemical test. We check. We start by open circuit potentials, and then some electrochemical impedance spectroscopy, and then continue by some polarization test. It was a static, dynamic, and also cyclic polarization. And then we continue with some surface characterization with standard scanning electron microscope. And also, since we are dealing with very thin film in the order of like 10 to 20 nanometer, so we use X-ray photoelectron spectroscopy to characterize the chemical composition and also the phase or the compound found on the film. And we also use atomic force microscope to study the dissolution during corrosion test. And for the analysis, we use Mott-Scotty technique and also high field and anodic dissolution and growth model. High field anodic, this is high field anodic current. And as mentioned before, our main tools for this research was an atomic force microscope. And this is a electrochemical result or electrochemical behavior of our alloys. It has, we can reach a stable open potential, open circuit potential after very long time. So it's after 6 hours minimum. So we are sure that we have some stability, except for the pink one, which is high entropy alloys with the lowest niobium content. And then we continue with cyclic polarization to check how it behaves, whether there is passivation, and then we return the potential. So in this is actually polarization curve. So we scan the potential from lower to high, and then after that we return the potential from high to low. So it's like a cyclic to make a loop. Okay, and from that we can obtain some important parameters. And then we did some electrochemical impedance spectroscopy to characterize the dielectric behavior of the passive film. Okay, so from here we can obtain its corrosion potential. So everything compared to titanium 6Al4F and also to commercial pure titanium. And as we can see that the high entropy alloys has lower corrosion current compared to these two titaniums, and with high pitting potential, meaning it is difficult to induce pitting on the surface of these alloys. Okay, and from electrochemical impedance spectroscopy, we can have resistant some resistance, okay, because after we obtained this curve, we call it Nyquist curve, we did some fitting with this proposed electrical circuit model. So from this, we can obtain some electrical parameters, okay, like resistance of the solution, resistance of the film. There is also some capacitance, okay, or a mix of capacitance and resistance represented by this CPE, constant phase element. And also we have resistance of charge transfer. And from all this result, with some analysis, we see that high entropy alloys resist corrosion better than commercial pure titanium and Ti6Al4V. The high entropy alloys tend to form passive film easier than these two titanium. And the effect of niobium, it increases the film resistance and charge transfer resistance, as you can see from the electrochemical impedance spectroscopy result. Okay, so that's those are good news. And then we continue our characterization using AFM. This is some images obtained from the AFM. From here, we can characterize the roughness of the surface, and from that we can get some analysis on the dissolution rate. So based on these AFM images, we see that the content of niobium, with the increase of niobium, the dissolution rate decreases. And from the and then this is the current density to time. So we do some it is like electrochemical noise, but not really that. So we monitor the current density over time, and we see some activities, small activities, but it's like disturbance to the current, and it is related with the dissolution of some metallic elements from the surface of our specimens. Okay, and then we continue our analysis with X-ray photoelectron spectroscopy to check what actually presence on the thin film that form on the surface. So there are titanium oxide, niobium oxide, and hafnium oxide, and zirconium oxide. They mix together with this proportion. Okay, and then we conclude that in the passive film we have this kind of oxide into detail. So it's not only the elements on the passive film, but also we are able to distinguish what kind of compound form in the passive film. So like TiO2, NB2O5, Z05, O2, and HFO2. So this is after we analyze the XPS curve. Okay, and we continue then with some mathematical modeling. So based on the data, for example, here potential versus charge, okay, during the potential static test, we use the Mott-Schottky analysis using this mathematical equation. So based on the presence of oxide in the film, we conclude that the passive film has N-type semiconductor. So we use this equation. And from that, we can identify the number, division number.
Dr. Hendra, excuse me.
Yes.
Please faster your presentation.
Yes.
because
Okay.
time is
Okay.
very limited. Thank
Okay,
you.
for sure. Thank you. And then we use high field ion conduction model to find out the effect of niobium. Okay, from these two analyses, we see that the passive film behaves like an N-type semiconductor. So it is negatively charged, which is good. So the chloride ion, which is also negative, will not be attracted on the surface. And then niobium increases the passivation index and reduce the CBV. CBV is a parameter related to ion migration in the passive film. So it does improve passivity of the film. Okay, and then by using analytic dissolution and film growth model, we arrive to this conclusion that niobium reduces the donor density, thus ensuring a high density and compactness of the film. Niobium facilitates quick formation of the first uniform oxide layer that rapidly protects the entire surface while allowing a complete formation of the passive film. So these are the beneficial effect of niobium. It improves the passivity of the 4 passive film on our high entropy alloys. So that will be the end for now. This is the organization that support our research, Natural Sciences Engineering Research Council of Canada, the Canadian Foundation for Innovation, also this Research Center for Advanced Materials in our university, and University of Tennessee at Knoxville, Professor Peter Kelly, who provided us with the high entropy alloys, and also provided training for my students in making the alloys and characterizing it. So if you would like to know further about my research, you can start from my website as written here. So thank you very much. I return back the forum to the moderator. Thank you so much.
Thank you. Very interesting topic. But the time allocated by the committee are very limited, so open the presentation directly. We will turn the forum to the committee. Thank you, Dr. Hendra Hermawan, for the presentation. We will meet next time for further discussion. Thank you. We will return the forum to committee with okay, thank you very much. Baik, ada informasi dari panitia bagi yang ingin coffee break, ingin ambil kopi dulu di bawah di dalam ruangan, silakan di dalam waktu kurang 5 menit kita masuk ke sesi berikutnya. Terima kasih. Sambil menunggu kopi break, Pak Hendra, salam kenal.
Masih Pak saya Sifaul.
Shifaul ya.
Ya, Sifaul.
Sambil menunggu break. Nanya dulu kan seperti kita kalau yang ada berapa gitu ya. Plan. Ada pasti kalau ya. Sekarang tahu ternyata di kalau yang ada berapa
It's not really clear. I cannot hear you clearly actually. Since the beginning, maybe you have to change your microphone.
Cek. Oke, terima kasih.
That's clear.
Clear, ya, oke. Baik, I would like to ask Dr. Hendra one question. This question is outside the session. Actually, our session is finished, but
Okay.
while we wait for other to have a coffee break, I would like to ask you one question, if it is possible.
Yeah, sure.
Okay. In the past, we know that some prosthesis, for example, hip stem prosthesis, using titanium alloy kind of TI 6AL 4V material. But now that kind of material have a risk because it can corrode in the long term. So how about your material? Is it possible to be used for larger implant, such as hip stem prosthesis? Thank you, Dr. Hendra.
Okay. Thank you very much for your question. It's very interesting. Yeah, there are some studies showing evidence of corrosion on titanium 6Al4V implant. But in general, they are quite good. Okay, the risk of corrosion is very, very low. They already passed ISM standard corrosion test for medical implant and ISO standard in vitro, in vivo. So actually the risk of corrosion for this kind of alloy is very low. Also for cobalt chromium alloys and stainless steel 316L, because they are specially made for biomedical devices. So they are not processed just like other TI6L4V. Okay, they should go to like vacuum melting or even remelting to eliminate or to reduce the impurities to the minimum level possible. But some studies show there were evidence of corrosion, special localized corrosion on titanium 6Al4V stand, for example, and it was because of synergetic action of mechanics and also corrosion. So mostly because of the dynamic loading experienced by the stand. And for this high entropy alloys, this titanium based high entropy alloys, we cannot say much for now, because this is very early study. This is the first study on this corrosion study into the detail. We try to understand the passivation mechanism, and based on our comparison, yes, it has a better corrosion resistance to titanium alloys and to commercially pure titanium, but we still don't know yet how about its corrosion under a more in vivo closely condition. There are so many tests. So many tests must be passed by medical materials, okay, biomaterials like this, and we still don't know the real answer. But from this study, we can see that this titanium-based high-entropy alloys has better corrosion resistance compared to commercial Ti6Al, 4V, and CP titanium. So that's the answer for now.
And Raihan?
Okay, thank you very much, Professor Dr. Hendra Hermawan and Dr. Shifa Lusni for the keynote sessions fun. Can we give an applause to both of them? Thank you very much once again. And then, ladies and gentlemen, we will continue with the keynote speech. This time, it will be delivered by Dr. Insinyur M. Dirhamsyah MT IPU from Universitas Syah Kuala Indonesia. And the keynote speech will be moderated by Dr. Insinyur Muhammad Iqbal MT from Universitas Syah Kuala Indonesia as well. Both the keynote and moderator will join us at the venue. So we would like to invite here at the stage, Dr. Dirhamsyah and Dr. Iqbal.
Assalamualaikum warahmatullahi wabarakatuh, and very good morning for all of the participants of Icecme 2022. Thank you, Ms. Chairperson. Today, I am very happy to chair, inshallah, a very interesting session that will be delivered by Dr. Muhammad Dirhamsyah. So before we start the session, I would like to introduce our keynote speaker for this session. Muhammad Dirhamsyah got his bachelor degree in mechanical engineering from Mechanical Engineering Department of Syah Kuala University Banda Aceh, and then he continue his study in Industrial Engineering Department Bandung Institute of Technology, got his master degree, and then continue his PhD program, got his PhD degree in Mechanical Engineering from Mechanical and Material Engineering Department of Mechanical and Material Engineering Department of National University of Malaysia, UKM, Malaysia. Sorry. Currently, Dr. Muhammad Dirhamsyah is a senior lecturer, associate professor in Mechanical and Industrial Engineering Department, University Syah Kuala. And at the same time, he is Dean of Faculty Science and Technology from Islamic State University Ar-Raniri. Actually, he got a very long CV, got some professional membership from Persatuan Insinyur Indonesia, also from Engineer Association of Indonesia member, Cooperation Body of Mechanical Engineering, BKSTM Indonesia member since 2007, and a lot more, and also got some awards like Advisory Board of Aceh Barat Daya Regional Logistic Corridor ARLC 2015, and many more. Actually, I have very long CV since Dr. Muhammad Dirhamsyah got very long experience in both in academic and also as an engineers. But we have a very short time. So I think I would like to invite Dr. Muhammad Dirhamsyah to deliver the speech. Please, Dr. Dirham.
Dari sini kan Pak Dirham masuk ke Zoom bisa langsung presentasinya di Zoom. Langsung share screen.
Assalamualaikum warahmatullahi wabarakatuh. Thank you so much for the time, Iqbal. And thank you so much and appreciate join together today and this time. And I present about the state monitoring in adaptive and conventional manufacturers. Now, we are talking about the feature-based smart monitoring method application concept. It means this is some how we can create some about the feature-based for the conventional and adaptive manufacturing. As Iqbal says that this is my CV. Yeah, right now I'm as a dean of Science and Engineering faculty in Islamic State University at Araniri. So that beside of our school, the Siakol University. This is my professional memberships and some award from Native Fund and my my education. My present today about some illustration for Industry 4.0. There's some behavior pattern of manufacturing sectors. Because of some significant technological development for production sectors, some changes from the conventional static system to dynamic and adaptive. Also, they change some method of observation in manufacturing, and then change about the direction of our research also. Some of the process of observations are carried out for the directly to the missions, but the missions conventional and non-conventional missioning. Beside of this, I mean, our research, the computational method also inside of the system. It means we try to put the intelligent algorithms and how the information parameters using for recognize the signal of acoustic and vibrations. And the some patterns can be used for the informations and determining the characteristic of machine during the production processes. The result of observations can be used for the maintenance and the quality of productions, can predict about how we can maintain the manufacturers through the features. And this is what how I try to discuss today about the overview of my presentation. And we know about the 4.0 that changed more dramatically. Okay? It means we are trying to enable adaptive manufacturing technology over the opportunities in new era manufacturing, especially for the rapid prototyping. rapid prototyping using for the small scale productions, self-assembly structures, and revolution in manufacturers. But this is not suitable for the mass manufacturing because we are trying to make some prototype of products. The new era, but this is also the old concept. But right now, because of the so many production variety, we must also involve with adaptive manufacturing. We are using the automations for changing the stations. Adaptive manufacturing system, they are create and reactive for the order level. It means for the quick level, short production, for batch productions, and also supply chains information can be inside of our discussions. But the problem is how to set the parameters. The parameters can be good enough if we make the suitable cutting parameters, materials, and the designs. Some the automations. Automation is also the holy of the grail. The holy of the grail, and the 3D printing operation leave distinctive acoustic signatures. They are using the acoustic and some signals can be used for the condition manufacturing operation. The acoustic data, sorry, I put some laser pointer here. The acoustic data can be acquired the low cost and market ready sensors, such as microphone and accelerometers. And some algorithms can be also created. Our student created the algorithm designs, knowledge-based training features can be used for extract the signify features of operating 3D printers. And the signal of 3D printers can be inferred to create the information, and we can put the information as our monitoring in our operation in manufacturing. The state monitoring, we are very reason for installation monitoring system in manufacturing process. Modern manufacturing must be flexible, sustainable, operate with the minimum human interface, whereas machine tools must operate with the error-free. And this is what our hope, how we can use the error-free automations. Some information of the control. This is why we are looking for the control. This is a spindle, tools, workspace, clamps, table, acoustic emission sensors, accelerometer sensors, and also spindle holders. And one more, this is a sound microphone sensors. How we can put the data from machine operation here can be manipulated, and we can get the data from the sensors. For example, the others, for example, force, fusion, temperatures also can be involved the condition monitoring. This is what the concept of the conventional monitoring. The feature developments for the condition monitoring technique and system. Yeah, we have put the data acquisition system, condition evaluation technique, knowledge-based control methods, and also how to put the automation for implementation. This is what we try to think about the circle of our works. 3D printing machine also have the limited condition monitoring, such as minimize failure due to the nozzle clogging, because the nozzle clogging also depend on the environment temperatures and also the environment's situation in our manufacturing system. This is what the difference with the adaptive and conventional manufacturing features. And this is some supporting walls, holes, connecting part, internal features. We assume this is some fillers here, horizontal bricks, pin diameters, overhanging, over support walls. Some also the slot here, machine tolerance, minimum features, and also the ratio of aspect of design. Because of that features, we try to know about the characteristics of their working. For example, the tool parts and also the nozzle diameters and also the temperatures. The whole condition also can involve for how we can think about the monitoring the condition of the system. This is from the twist tail wear condition processes. And this is a CNC machine. CNC machine. And this is a CNC machine, but this is a conventional system because they are removing the material. If we are using the adaptive, we inside the material. For the conventional, they remove the materials. This is the phenomena. This is a phenomena of how the twist tail wears. We can looking for the grid effect for the bore information system. This is our student doing this. And also some information of the CNC machine. We are try to put the data here, data from the root mean square, feet, and we can look at the characteristic of the bore and also some chips removal. We can look some characteristic of the signal. For the adaptive features, we try to design with the 3D features, like I said before. From the 3D features, we have the digital, and from the digital, we have the feature extractions and how they are moving, the movement of the nozzle. From the movement, we create some signals and capturing by sensors. And the sensor, we are interpreters. The offline monitoring, we are using from acoustic like this. 3-dimension design, extractions, feature movements. Also this acoustic interpret and signal characteristic features, and also the vibration features. From the correlation condition monitoring from the movement, we tried, this is a movement feature 1, feature 3, feature 6, 2, and 3. This is the data of features training. This is a vibration training, and how we can make the correlation data sets. How we can make the correlation data set from the feature movement and the signal to the features. And this is what we try to put some ideas and algorithm how to looking for the system works. This is for example correlation of features. The database of all features. We try to make the domain feature characteristic. We have the knowledge-based training features, and how we can put the open source data, and from this correlation, we try to make the decision making, and how we put the data visualization to make some decision of our movement of the data. this is some condition monitoring with the artificial intelligence. For example, this is our 3D printings, how we can put the quick chambers. We put the data here, how we try to capturing the data. We are doing this in the UKM laboratory, and we put the data analog here. We put the big data here. We make the processing data, and how to identify the condition of indicators. And we make the trends model using the artificial intelligence. We creating the similarity conditions, fault identification, misalignment, nozzle breakdown, density and speeds. From the all data, we have the post-processing using the artificial intelligence combined with the signal analysis and deploy and integrate the risk. This is a training, and we try to make the best fit solutions, and we have the performance. This is the cycle of condition monitoring using the artificial intelligence. This is some monitoring of signals. It means this is a nozzle with some variation of diameters, 0.4, 0.6, and 0. And how we create the data like this. This is a signal, a sound pressure signal. This is sound pressure signal, and this is a vibration signal. From our visualization, this is not very enough how to analyze. We must use the some analysis for the make the data here. For example, with the skewness, crest vectors, and some signal processing. And this is also some ideas. Yeah, this is a layer by layer production using 3D printing. This is the density of 10%, 50%, 100%. The layer 1 and the above and uppers the same, but in the middle they are different because of different density. The density of 10, we are looking for this for narrow, okay? And this is more solid for density 10. We can look the signal here using the accelerometers. We try to divide how we can calculate the data and how we can create the data to monitor the system. And this is also the some density with 0.6. And this is for the features for circle. We try to find the bad, the worst and the good one. We try to divide how we can identify the signals. And also this is another set of experiment with the around features, and also we can looking the some spatial signal here. We try to put this is index. We try to create the index with the cylinder test. This is my conclusion that the effect of nozzle diameter and filament density, using the vibration signals, we can measure and analyze. Based on the result, also we found some effect of measures, vibration, and sound of occur the machines, and how we can put some knowledge-based system inside the program to calculate and monitoring the condition of machine. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Muhammad Dirhamsyah, for very interesting speech. I would like to open a question and answer. Please, the floor. Dr. Iskandar, maybe. Okay. Dr. Dirhamsyah, I have one question actually. When we talk about industry, our general understanding is industry that related to manufacturing industry. But however, today industry become very wider application. I would like to get your opinion, ideas based on your experience, the possibility to relate this industry to, for example, agriculture, transportation, and even that industry that we can see around us today, like hotels and hospitals, maybe. Please, Dr. Dirham.
Thank you, moderator. And that's very good question, that how we can implement it, our feature base. Actually, feature base, this is a basic of CAD system. It means computer-aided design based on usually designed by features, feature recognition. How we can use the features combining that every features, but how to make the component of agriculture, for example, for the equipment for household equipments, and how we can use for transportations, how we can put in electrical mobile, for example, and electric car. So many components we can create by features. It means we try to combine that features and also how to manufacture the features. That's medical also. That's because very difficult, safe. Yeah? The unsafe system. But this is very good if you are using for the 3D printing, because 3D printing also right now not only STL data, but they can create some data and also material with the steel. And this is so many changes now, the adaptive manufacturing, and also for the small batch, we can use that parts. For example, this is for the old patient, this is for the young patient, and how we can create the special tools and part to the special purpose. That's the ideas. Thank you, Pak.
Thank you very much, Dr. Muhammad Dirham, for very interesting ideas. Maybe after this, we could start some cooperation between engineers and medical doctors, and we can come up with some solution for medical problems, and then maybe we can find a new better equipment or even tools and some methods that we can implement some engineering method and tools in medical worlds. With that, I would like to ask all of the participants to give a big applause for Dr. Muhammad Dirham. Thank you very much. Then we end this session. I return the session to the MC. Thank you very much, Raihan.
Thank you very much, Dr. Iqbal and Dr. Dirham Shah. What a beautiful keynote sessions. And then we will move on now to the next keynote speech, which will be delivered by Bapak Insinyur Jaka Kirwanto, IPU, the Operational and Production Director of PT Pupuk Iskandar Muda Indonesia. And the keynote speech will be moderated by Dr. Insinyur Dandi Bahtiar MSc from Universitas Syah Kuala Indonesia. Bapak Jaka Kirwanto will join us via Zoom online, while Dr. Dandi will be moderating from the venue. Bapak Jaka, are you with us?
Okay, hello. Assalamualaikum.
Waalaikumsalam. All right.
Is there
Thank you.
my voice? Okay.
Yes, very
My voice
clearly.
clear?
Yeah. Yes, clear. Very clear. Thank you, Bapak Jaka. Well, ladies and gentlemen, please welcome Dr. Dandi Bahtiar.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Thank you very much for the time for this session. This session is for keynote speaker with the presenter Bapak Jaka ya. Insinyur Jaka Kirwanto IPU. Yeah. Before the presentation, I would like to introduce the profile of Bapak Insinyur Jaka Kirwanto IPU. He is the Director Operasi and Produksi from the PT Pupuk Iskandar Muda. In this CV, he was born in Klaten, ya, lahir di Klaten at 5th October 1965, and he got the chemical engineering degree from University of Gajah Mada at 1980. Yeah. And before this, he hold the general manager production in PT Pupuk Iskandar Muda. He have the expert in process engineering and project engineering. For now, Insinyur Jaka Kirwanto will present the presentation about the Pupuk Iskandar Muda with the title Pupuk Iskandar Muda Creating Future, yeah, which describe how we plan strategic action to create our own future. Yeah. Now, time for Insinyur Jaka Kirwanto to present his speech. Please, Insinyur Bapak Jaka Kirwanto.
Thank you, Mr. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. First of all, on behalf of PT Pupuk Iskandar Muda Management, we would like to thank to University Syahkuala, Mr. Chairman, special thank to committee for inviting us to present PIM paper in this conference. Let me share our paper. Okay, my name is Jaka Kirwanto. I am operation and production of PT Pupuk Iskandar Muda. Maybe bigger of presentation. Okay, thank you. I'm sorry. How long we have time for presentation, Mr. Chairman? 30 minutes, yeah, I think, yeah. Okay, I will continue our presentation. I hope this presentation will be useful for us. We start the presentation, Pupuk Iskandar Muda Creating Future. Creating Future is our motto, Pupuk Iskandar Muda motto for 40th years birthday at this year, at February this year. Next. This is our profile. I am from Gajah Mada University, and now I assigned to be production director of PT Pupuk Iskandar Muda. Next. Okay, next, Mr. Irwansyah. This is our outline of my presentation about business overview, business challenge, PIM opportunity, unlocking values, and creating future. Next. This is our business overview. Then we have at a glance, Pupuk team at a glance, we have to plan to ammonia plant that capacity is, the sand capacity is more than 700,000 metric ton per year. We have to urea plant that capacity is more than 1 million metric ton per year. Our consumption, cash consumption is at about 110 metric million standard cubic feet. That is for feedstock, natural gas consumption, for processed gas, 60%, and for fuel, ammonia and for fuel utility at about 40%. Next. Is there any problem with connection? Okay, this is our business integration. We have ammonia plant. Ammonia plant is fed from air, ambient air, and natural gas feed to ammonia plant. And then from ammonia plant, we produce CO2 and ammonia. CO2 and ammonia sent to urea plant. From urea plant, we produce urea. Urea is to kind of urea we as subsidized and non-subsidized. From ammonia plant, we send ammonia to NPK plant, and from urea plant, we send urea to NPK plant, and then we produce NPK. NPK as new product for Pupuk Iskandar Muda. Our capacity of NPK plant is 500,000 metric ton per hour. We hope end of this year we will produce NPK plant. Now still under construction our plant. Next. This is our operation milestone of PIM1. We have commercial running since 1985. Commercial running for PIM1, and then 2005 ammonia and ammonia 1 stopped due to limited gas supply. We have a problem that there was a shorted gas, so we stopped ammonia 1 plant. And 2011 we start again reactivation. We start PIM1 only for 3 months. And then 2019, not only ammonia plant, but we also stop urea 1 plant. 2022, this year, we reactivate PIM1 and successfully done. So we start ammonia and urea plant after reactivation after 10 years not operation. Next. This is our operation milestone for PIM2 construction at 1999. And then for 2005, we have commercial running, but PIM2 was not optimally running due to limited gas supply. We have a problem sorted gas 2, so PIM1 not operate and PIM2 not optimally running. At 2020, we Medco already running, so our gas is better than before. Next. Our next key area is Iskandar Muda Industrial Area. Iskandar Muda Industrial Area is it was Aceh ASEAN fertilizer plant. It is used plant since 2003, and then it was owned by Pupuk Iskandar Muda since 2018. and being optimized to develop some of further industries. So at 2021, whole plan dismantled, and now the area ready for new industry. The plan is already for new industry. The vacant area at about 100 hectare. At that Iskandar Muda industrial area, there was interconnection facilities. We have filter water, we have power system, we have the main water, hydrogen, steam high pressure, and we have gas integration. Next. For business continuity of Pupuk Iskandar Muda, we have 5 principles. That is feed low cost, production high value, energy low, reliability plan, and safety high. So for feed low cost, why we need feed low cost? Because 60 to 70% of total production cost is from feed. So from natural gas. So mandatory we need feed low cost. For production high value, we will produce environmental friendly product like blue ammonia and green ammonia. For energy low, some utilities uses we will convert to PLN, electric state-owned company. So we will use our natural gas to produce more product, because some of utility users will convert to PLN. For reliability, we have maintenance excellent program. And then for safety term, we need zero accident commitment. So we have to zero accident. Next, for business challenge, we have 3 key areas. PIM 1, PIM 2, and IMIA, Iskandar Muda Industrial Area. For PIM 1, we have challenging, very challenging, because PIM 1 is vintage technology. There is a high energy consumption of PIM 1. There is high energy consumption. We have problem shorted natural gas. We have problem obsolete spare parts, and the control is still pneumatic control system. So that is very challenging to run again PIM 1. For PIM 2, we still have problem of shortage gas. So PIM 2 is not optimal running, because we need at about 55 metric million standard cubic feet day, but the gas is only at about 45. So our plant is not running optimally. We run minimally rate of gas. It causes not optimal plant. And for IMIA, in the Iskandar Muda Industrial Area, we still have wide area for vacant. We there is availability of utility facilities. We have still idle hydrogen peroxide plant, and we have idle warehousing. Next. What about Pupuk Iskandar Muda in future? In future, we have so big opportunity for gas supply. There is the map. There is so big opportunity, because so many gas sources at Aceh. Now PIM is sorted gas. We are still supplied by only Medco. still shorted gas from Medco, but in future we have so many sources. Let's say number 5 from Andaman 3, there is so big gas sources. Still exploration from AMP Kebang 1, still exploration. Maybe at next year will operate and will on stream and send to Pupuk Iskandar Muda. We have already MOU with AMP Kebang, so at 2023, AMP Kebang will send process gas to Pupuk Iskandar Muda. For the second step, AMP Kebang 2 will send to Pupuk Iskandar Muda, AMP Kebang 2, but at about 2028. At 2023, AMP Kebang 1 sent at about 40 metric million standard cubic feet, and at the second step at 28, AMP Kebang 2 will send to Pupuk Iskandar Muda 100 metric million standard cubic feet. Next. This is our opportunity. So our motto is creating future, because we will create our future to better living of Pupuk Iskandar Muda. We have so many opportunity. We state for gas source near to potential gas source Kebang and Andaman. There is very big opportunity for gas source. There is interconnection gas from Arun to Belawan. So for gas source, it is very big opportunity for Pupuk Iskandar Muda. There is facilities and infrastructure. We have so wide vacant area at IMEA, close to the port, and land conditions are ready for the construction of industries or warehouses. We have strategic location. We have strategic location because there is international trade route, Strait of Malacca, and then special economic zone of Arun Lok Sumawe. We are stayed at special economic zone at Arun Lok Sumawe. And for utilities, we have water resources from Pasangan River, and then potential green energy resources from Selawah. Then next. How to unlocking our values. There is our key areas for PIM1. We will develop blue ammonia. So blue ammonia will environmentally friendly. There is three kind of ammonia. Yeah, green ammonia. Green ammonia is like we have now existing ammonia plant, like we have currently ammonia plant is green ammonia, and then we in future we will develop blue ammonia. What is blue ammonia? Blue ammonia is our CO2 product will be injected to deep well to increase capacity of the well. So it will be environmentally friendly for us, because CO2 will be captured and sent to deep well. And then the third ammonia is green ammonia. Green ammonia is renewable energy. So the feed is not from natural gas, but from hydrogen, from hydrolysis of water. So it will very environmentally friendly. For PIM2, our unlocking is energy conservation. Energy conservation, we will develop green ammonia, and then maybe we will we plan to develop diesel exhaust fluid. For industrial Iskandar Muda Industrial Area, IMEA, we will develop green industries area. We will develop green industrial zone at IMEA. And then we will reactivation hydrogen peroxide plant. We have a hydrogen peroxide plant already not operation since 2003. Hydrogen peroxide plant is belonging to AIF plant, but AIF plant not operated since 2003. And then now hydrogen peroxide plant will be reactivated by PIM. Our target next year, we will operate our hydrogen peroxide plant. And we will develop ammonia hub trading. Now we only have storage, ammonia storage, that capacity is only 10,000 ton, and we will develop to higher capacity. And then for NPK plant, this is our portfolio, new portfolio plan. This is our new product plan. The plan, NPK plan, now under construction. We hope end of this year, we will produce new product, NPK plan. This is our export oriented, yeah. Next, this is our creating future. We want to present, this is our presentation about where will Pupuk Iskandar Muda go at the future. This is our creating future. This is our map of currently condition and Pupuk Iskandar Muda future. Now from natural gas, we send to natural gas to ammonia plant. Please, the most is Irwansyah. From natural gas, we send to ammonia plant. From ammonia plant, we produce ammonia and CO2. In the future, CO2, it will be injected to the deep well to increase capacity of well. From ammonia and CO2, we will send to urea plant, and then we will produce urea. From urea, we have two products, urea granule and urea pril, and then we will product to diesel exhaust fluid. From ammonia plant, we will send to hydrogen peroxide plant. We will reactivate hydrogen peroxide plant belonging to AIF. It used to at 2003, and then the product maybe we will export or in domestic consumption. From urea plant, we will send ammonia and urea to NPK plant. And then from NPK plant, we will produce NPK product that oriented is for export. And the future, from natural gas, we will develop, we will build, we will construct a new plant that's called blue ammonia, and maybe we will develop to a methanol plant too. And then for the last, we will develop to green energy. For green energy, from electrolyzer, and then we will produce green ammonia. Next, this is our journey of PT Pupuk Iskandar Muda. Our vision is to be competitive fertilizer and petrochemical company. Our corporate strategy is focusing on commercial product and asset utilization. At 2020, our product is urea. This is our just only one plant, yeah, 2020. Our product is only 570,000 ton, and our product of ammonia only one plant. the production is 396,000 ton. This is our journey at 2022. Now at 2022, we will reactivate PIM1 and already reactivate, and we will start Kaltim 1. We build a new line interconnection facilities. 2023, we will produce, reactivate hydrogen peroxide plant, and we will build new ammonia tank, and then we will make commercialization of IMEA asset. At 2024, we will develop new ammonia urea plant, expansion, and new methanol plant. We have a plan to build a new plant. And then 2088, our future, we will have ammonia plant, new ammonia plant, we will have urea, new urea plant, we will have new methanol plant, because we have a new source of gas that is big opportunity for Pupuk Iskandar Muda. Next. This is our conclusion, our remarks. PIM currently has 2 units of ammonia and urea plant, but only operating 1 plant due to limited of raw material. Currently, we have limited of raw material. Second, currently, PIM continues to strive for the availability of raw material for plant operation and development plans. There is a potential of natural gas in the Gebang area of 100 metric million standard cubic feet and several other potential gas resources around North Aceh. The potential gas resources above will maximize PIM production, and there is the potential to build a new ammonia, urea, and methanol plants. PIM is in the state of completing the NPK chemical 500,000 metric ton per year, and is planned to be commercially operational by the end of 2022. In order to support of the new zero emission 2060 program, PIM has initiated decarbonization program such as the use of renewable energy, blue ammonia, and green ammonia. And the last, PIM developed program is expected to encourage Aceh economic growth and become a locomotive of industrial growth, especially in the special economic zone around Lok Sumawe. I think that's all for our presentation. The time I back to Mr. Chairman, please. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much for the presentation from Bapak Insinyur Jaka Kirwanto. Yeah, the nice presentation about the whole profile and the role and contribution of the PIM, Pupuk Iskandar Muda, for the development of Aceh. Yeah. Maybe we have about 5 or 6 minutes for the Q&A. Yeah. Any question from the floor? I think. Yeah. Please, Mr.
Thank you. One question from me, Mr. Jaka. It was a great pleasure to hear that you are reactive the PIM1 after 10 years. The plant is not operating. Can I ask, like, one biggest challenges that you are facing during the attempt to, to reoperating the PIM1? maybe you can share with us what is the biggest challenge that you facing during the attempt. Thank you.
Okay, thank you. Directly I answer or with another question, Mr. Chairman?
I think we can answer one question, and then if we have time, we can deliver to the second. I think.
Okay, okay. Thank you very much. Thank you very much, Ibu. Sorry, I don't know her name. Okay, okay, Miss. I will ask about PIM1. PIM1 already not operation at about 10 years. Yeah, we last 10 years ago we start only 3 months. The biggest challenging to problem. First is about reliability of plan. Reliability of plan. This is old plans. So the first problem, first challenging is reliability of plan. We have to reactivate. We have to maintain. We have to repair all of equipment. This is the very big challenging. The second one is the feedstock. Now we have no natural gas supply. Now currently, we have no gas supply. So we asked the government to supply LNG. You know, Bu, LNG now. How much the price of LNG now? For export LNG is the price is $42 per MMBTU. So it's very expensive for us because our economically price is only maximum 10. Our economically price is only maximum 10, but the price at the spot market, if we export LNG from Indonesia, more than 42 US dollar per MMBTU. So we asked to President, we asked to Minister, Energy Minister, and then now Mr. President, now Mr. Minister give us two cargo, give us to shipment to Pupuk Iskandar Muda because Aceh is very interesting for government. Yeah, so government give us LNG to shipment, and maybe next week, first shipment will come to Arun. This is very we are so grateful to government because PIM is given to shipment LNG. That is the price is very economically for us. I think that's all, Ibu. First challenging is our reliability plan. Very challenging because this is old plan and 10 years not operated. So we have to maintain, we have to make everything is reliable to run again. Thanks, my explanation.
Satisfied?
Yeah, that's fine. Thank you, sir.
Okay, thank you. I think we have still 1 minute. Just last question from me. Any contribution of the PIM about the green energy? I saw in your slide about the CCUS or CCS. Any contribution from PIM about this trend?
Okay, thank you very much for green energy. Now, before I came here to this conference, I met delegation from Mitsui and I met delegation from Toyo from Japan. We discuss about green energy and about green ammonia and about blue ammonia. We have memory of memorandum of understanding with Mitsui. We have MOU with Toyo to develop green ammonia and blue ammonia. And then they came here, and just now I discussed with them to develop blue ammonia and to develop green ammonia at Pupuk Iskandar Muda area. So this is our contribution to friendly environmentally. I think that is our contribution. We hope that in the future we develop blue and green ammonia at Pupuk Iskandar Muda area. That's all.
Yeah. Bapak Insinyur Jaka Kirwanto, thank you very much for the nice presentation. And for the last week, we can give the applause, big applause for him. Thank you very much. Yeah.
Thank you very much.
Okay, now we deliver to the Ms. Raihan.
All right, thank you very much once again to Bapak Jaka Kirwanto and Dr. Dandi Bahtiar for the keynote sessions. And then the next agenda, we would like to present a token of appreciation. We call it Bungong Jaro in Bahasa Aceh, to all our keynote speaker for sharing your expertise in the session. And to present the token of appreciation, we would like to invite the General Chairman of the fourth Icecme, Dr. Teku Edi Saputra, and we also invite Dr. Dirhamsyah as the representative of all keynote speakers to receive the Bungong Jaro. So, yeah, here is the appreciation, token of appreciation. We call it Bungong Jaro in Bahasa Aceh. It's our way to say gratitude for our keynote speakers in the fourth Icecme 2022. And we also have one for Associate Professor Dr. Hendra Hermawan from University Laval, Canada, and also one for Insinyur Jaka Kirwanto from PT Pupuk Iskandar Muda Loksmawe. And for all the keynote speakers who can't attend this conference via offline, we will send the token of appreciation right to you after this conference finish. Thank you very much. Thank you again for Dr. Teku Edi Saputra, Dr. Dirhamsyah, and all the keynote speakers. So this is the end of the opening ceremony of the fourth International Conference on Experimental and Computational Mechanics in Engineering, Icecme 2022. The next sessions for attendees is the parallel sessions, which will be divided into several Zoom rooms and also offline at the venue. So please refer to your program book for the session's details. I am the master of ceremony for today's event. Would like to say thank you and hope you have a pleasant time during the conference. Wassalamualaikum warahmatullahi wabarakatuh. Okay. All the participants, we have divided several Zoom rooms for online participants. So you can join the breakout room with revert to the book of programs. So you can choose which rooms are you going to present your paper right now. You can refer to the schedule at the book of programs, book of abstracts. So you can choose which Zoom room will you be presented today. for Dr. Teku Edi Saputra, Dr. Dirhamsyah, and all the keynote speakers. So this is the end of the opening ceremony of the fourth international conference on experimental and computational mechanics in engineering, Icecme 2022. The next sessions for attend.
menjadi perusahaan pupuk petrokimia yang kompetitif. Visi ini mendorong kami untuk memberikan yang terbaik. Pupuk Iskandar, anggota holding dari PT Pupuk Indonesia dalam ketersediaan dan penyaluran sejak dulu. Indonesia terkenal dengan kekayaan alamnya yang luar biasa. Tentram,